Hey everyone! Back in December 2024, NVIDIA launched the Super version of the Jetson Orin Nano Developer Kit, with a significant jump in performance for running AI models locally. But here's the best part, they also dropped the price of this kit to around $250, which made it a lot more accessible for DIY developers like me. In this video, I'll be unboxing my new Jetson Orin Nano Super Developer Kit and setting it up using the NVMe SSD method. I will also be sharing the setup issues I ran into, along with how I managed to fix them. So if you're planning to get one or already have one of these, stick around. So let's get started. I've got the Jetson Orin Nano box right here, and you can see all the specifications listed on the back. You might be wondering, how does this compare to something like a Raspberry Pi? Here are the specs side by side on the screen. If your projects mainly involve simple tasks like controlling motor or reading sensor data, a Raspberry Pi will do just fine. But for anything AI related like computer vision, deep learning or autonomous robots, the Jetson Nano is far superior in performance. With its 67 trillion operations per second and 1024 core GPU, the Jetson is built for serious edge AI computing, which basically means running an AI model locally on the device without using the internet. Let's start unboxing. Right on top there's a small manual, and on the right we have got the Jetson Orin Nano itself. The manual talks about the board features, and we will take a closer look at those soon. Underneath there is a power adapter that converts to 19V DC for the board. They have also included both the EU and the UK plug options. So this is the Jetson Orin Nano. As you can see, it comes with the Orin Nano module, which sits on a carrier board. The module houses the CPUs and GPUs, and that's where all the processing happens. These are the features on the carrier board. There's a barrel jack for 19V DC input, a DisplayPort connector for your monitor or display. There are 4 USB 3.1 Type A ports for peripherals like keyboard, mouse, etc. There is an Ethernet port, and there's a USB-C port which should only be used for data connection. It cannot be used to power the board. On this side of the board there are 40 GPIO pins. This is similar to the GPIO pins on the Raspberry Pi. And on the other side there are 2 CSI camera connectors. On the back of the carrier board there are 2 empty slots for SSDs, such as this NVMe 2280 SSD, which we will soon be installing. Right below the Orin module there is also a MicroSD card slot, along with a set of header pins. We'll use these header pins to boot the Jetson in recovery mode during the installation. To set up the Jetson Orin Nano, we will first need to flash Jetpack onto it. Jetpack is NVIDIA's Software Development Kit, or SDK. It includes the Ubuntu Linux operating system, all the drivers for GPUs, as well as the toolkits and libraries needed for AI development. There are 2 main ways to install Jetpack. The first and the simplest is the MicroSD card method, and the second is the SDKManager method. The SDKManager method lets you install Jetpack directly onto a NVMe SSD instead of a microSD card. And if you are after better performance from the Jetson Orin Nano, using an SSD is definitely the way to go. NVMe SSDs are much faster than a microSD card, and also far more reliable for long-term use. Since I'm planning to use the Jetson for edge AI projects, where the computational speed matters, I didn't want a microSD card slowing things down. Hence for this setup, I will only be using the SDKManager method with an NVMe SSD. There are few additional requirements for this method. First of all, you will need a PC running either Ubuntu 22.04 or 20.04. This is important as the SDKManager isn't supported on other operating systems. Next, you will obviously need an SSD. It has to be an NVMe PCIe Gen 3 SSD. It can be of either 2230 or 2280 form factor. I'm using this 1TB Gen 3 SSD in the 2280 size. The Jetson doesn't support the Gen 4 SSD speeds, so even if you are using a Gen 4 SSD, it will still be limited to run at Gen 3 speeds. Since Gen 4 and even Gen 5 SSDs are more common these days, I had to do a bit of searching to buy a Gen 3 version. But you should still be able to get one online. Next, you will need a USB-C cable to connect the Jetson to your PC, and a jumper pin or wire to put the Jetson into recovery mode. I also had to buy this HDMI to DisplayPort adapter to connect my screen, since the Jetson doesn't come with an HDMI port. We will start by installing the SSD on the back of the carrier board. First, remove the screw and insert the NVMe SSD in the slot provided, and then fasten the screw to secure it in place. Next, using a jumper pin or wire, we will have to connect the FC-REC pin to ground. This will put the Jetson in forced recovery mode. So connect pin 3, which is a recovery pin, to either pin 2 or pin 4. I didn't have a jumper, so I'm using 2 female head wires connected together. Also get the USB-C cable ready to connect the board to the PC. And plug in the power adapter for the mains connection. But don't power it on just yet. As I mentioned earlier, you will need a PC running Ubuntu version 20.04 or 22.04 for this process. Here I'm using my laptop running Ubuntu 20.04, which I had set up earlier through disk partitioning. For this tutorial, I will be following the steps from this JetsonAILab.com page. The first step is to create an NVIDIA developer account. You can do this by visiting developer.nvidia.com and signing up for a free account. The next step is to install the SDKManager on your Ubuntu system, which you can do by following this link on the page. Click on the .deb Ubuntu installer link to download. Or if you prefer using the terminal, you can enter these commands instead. Once the SDKManager is installed, you can launch it by typing SDKManager in the terminal. In my case, I got a message saying that the system requirements weren't met. That's because my laptop has 7 GB of RAM instead of the recommended 8 GB. One possible fix is to reduce the concurrent file download setting in the SDKManager. However, I didn't actually need to do this during the installation. I just clicked yes to continue and the SDKManager window popped up. If this is your first time using SDKManager, you will also need to log in with your NVIDIA developer account before proceeding. As you can see on the screen, the target hardware is still showing as unconnected. So now it's time to connect the Jetson to the Ubuntu system. But before that, make sure the board is in recovery mode. Double check that the jumper pins are properly connected, and that USB-C cable is plugged into your laptop. Switch on the mains power to the Jetson. As soon as you power on the Jetson, a dialog box should pop up. Choose the developer kit version and click OK. Uncheck the host machine, leaving only the target hardware selected. As you can see, the SDK version I have is Jetpack 6.2.1, which was the latest version at the time of this recording. Then click Continue to step 2. In the next step, uncheck the Jetson runtime components since they can be installed later, leaving only the Jetson Linux components selected. At the bottom of the screen, you can see the disk space requirements for the download. Now accept the terms and conditions and continue to step 3. You will get a message saying that the folders need to be created. Click Create and click Continue again. After that, you will be prompted to enter your sudo password. Once that's done, a dialog box pops up saying that the SDKManager is checking system readiness for the installation. And then it moves on to step 3. Step 3 is where the Linux is downloaded and flashed onto the Jetson. First, the downloads for drivers and the file system images will start. Let's fast forward to once these downloads are complete. Once the OS images to flash are ready, you will see this dialog box pop up. Under the OEM configuration, select Runtime. And since we are using an NVMe SSD as the storage device, choose NVMe from the drop-down menu. Now click on Flash to begin the flashing process. Now this is where I ran into an issue. Before the flashing process could start, an error message popped up saying that the Jetson device isn't ready to flash, and that the problem is likely due to USB connection. I tried all the recommended fixes mentioned here: unplugging the USB, disconnecting the Jetson power cable, restarting the system, etc. I even swapped my USB cable for a brand new one, but this problem still persisted. To check if the USB connection is being recognized by the system, I tried the command lsusb in the terminal and found that NVIDIA was indeed present in the list of USB connections. So clearly there was something else wrong with the connection. After combing through the forums and trying multiple things, I finally figured out the root cause. It was due to auto-suspending of the USB connection. You see, during the flashing process, Jetson may need to be restarted few times. But on my Ubuntu system, the default setting automatically suspends USB devices after just 2 seconds of inactivity. This setting is defined in the Autosuspend file under USB core parameters. The default value of 2 here means the USB connection is suspended after 2 seconds of no activity. To fix this, I needed to change that value to -1, which completely disables USB Autosuspend. This is how to do it using the terminal. We will need super user permissions for this, so we will first open a sudo shell. We will then write -1 to the autosuspend file using the echo command. Write the full path to the file. And that's it. The autosuspend should now be disabled. When I ran the SDKManager flashing process again, it finished successfully without any errors. Now that the Jetson is flashed with the operating system, we are ready to boot it up. We will first remove the jumper cable since we no longer need the recovery mode. Then connect the display to the DisplayPort adapter and power cycle the Jetson. After a few seconds, we should see the NVIDIA logo on the screen and the Jetson booting up normally. You will then have to complete an initial software configuration. So now I have installed the initial setup and this is how the desktop looks like. You can see some of the pre-installed apps right here. There wasn't a browser installed by default, so I had to install the Chromium browser. And on the top right corner, you will see 25 watts, which is the default power mode on Jetson Orin Nano Super. If you click on power modes, you can choose different limits, 25 watts, 7 watts or Max and Super. Max and Super is the uncapped power mode which unlocks maximum performance on the board. But it may also throttle the performance if the power draw exceeds the thermal limits. We can also run this Jetson Power GUI, which displays a ton of stats on CPU load, GPU load, temperatures, fan speed, and more. This can be quite useful to monitor the performance of Jetson while you are running a program. Another way to monitor the performance is using JTOP. For this, we'll have to first install Jetson Stats, which you can do using pip3 install command here. I will leave the Jetson Stats link in the description. Once that is installed, you can simply run JTOP in the terminal. I'm using a terminal app called Terminator, which lets me open multiple terminals side by side. This is really handy for monitoring. On running the command JTOP, you can see the live stats up on the terminal. This includes the CPU usage, GPU usage, the sensor temperatures, and more. Let's run a program and watch the GPU usage. Here I'm running a local LLM model, Mistral, using Ollama. Ollama lets you run LLM models locally, and I will leave the link in the description on its installation. When I give Mistral LLM a prompt like, "What is the purpose of life?" you can see the GPU load spike up as the model generates its response in real time. And that's it for this video. I would love to hear from you. Let me know in the comments how you get on. I'm eager to try out many different projects on my Jetson Nano. So thanks for watching and I will be back with a new DIY video.